Hi everyone, so this video provides a few exercises in creating the ER diagram. So before we proceed, we should recall the elements of the ERD. Remember that the ERD should contain three important elements, that is an entity, attributes and also the relationship. The entity in simple word is an object, any object that holds the data. And then they have the data known as a features or characteristics. So this is known as an attribute. Okay, and when we want to connect one or more entity, we need an association. So this is named as a relationship, and the relationship has something to do with the business rule. So business rule is used to recognize, to identify the relationship between the entity and another entity. So this illustration gives a more understanding on the entity, attribute and the relation. Okay, so entity name is an object. So example as car, student, book, room, building and many more. Meanwhile, the attribute, okay, is a property or characteristic of an entity, like color of car, student name, student ID, student program, okay, car manufacturers, building name, building room, building color and so on. Okay, and meanwhile the relationship is usually used using the verb phrase, must use the verb phrase to identify the association between the instances. So we use the verb phrase, okay, to recognize it as an association. For example, blue car belongs to student Jack. Okay, so belongs is the verb phrase. So in the this is another representation of relationship using the cross foot. Okay, so you can see from here it must be verb. So the relationship must be presented as a verb. Okay, and the rest, the entity is usually written as a noun. So we have here a relationship one-to-one. Okay, one-to-one. Another, this is a one-to-one. This is a participation or cardinality, means optional participation. Same goes to this one, and this is one to many, one to many, many to many, and also many to many. The difference is if you have this notation, this is an optional. Okay, optional. So it gives us also optional participation. Participation. And 1 is the minimum number of a full participation. That is known as a mandatory. It is a must. Mandatory and optional participation. So this is the relationship. And to know the relation and also to retrieve back the value that is kept in the table of entity, we need an index. So the index use a key. So the key must be unique. So that's why for each table we should declare a key. So the key is known as a primary key. Okay, and it must be unique. So this is the simplest way to understand the primary key. It must have the ability to uniquely identify the data and is connective. Okay, so this is a business rule. Okay, so this is an exercise from here. Given is a business rule. Each customer can place many order, and each order is placed by only one customer. So from here you need to identify the object or the entity. So from here you can see this is the customer and order. Okay, and the verb or the relationship is a place, can place. Okay, so each customer can place many orders. So you can draw using either Proudfoods or chance. So this is customer and this is an order. Okay, so each customer can place many orders. So make a connection here. So each customer can have many orders. So no other constraints or situation is given. So we do not know whether this is a full mandatory participation or optional participation. So logically, we can have none. Customer made a null order, but usually it is not a customer when he did not make any order, okay, to that place. And each order is placed by one and only customer. So how to understand this? This is the to read from here, order to the customer. Here we can understand this is 1 to 1, and this is actually from 1 to many. Sorry, should be like this. Okay, from 1 to 1. Minimum and maximum is 1. Minimum is 1 and maximum is many. So we need to read it from the minimal value. This is 1. Okay, each order is placed by one and only customer. Only one customer. Okay, so this is place. Okay, place. So another example, a department employs one or more employees. So you need to identify which one is an entity. That is clearly department and employees. Okay, so give the relation employees. Okay, a department employs one or more employees. So a department employs one or more employees, and an employee is assigned to one department. So you can actually write both direction. Department employs employees, and the other one, and employees is assigned. You can write it also in this way, but usually they only write one relationship name. Okay, next, a customer may purchase multiple products. So here, customer and product. Customer, product. So the verb is purchase. The relationship is named as purchase. So a customer may purchase multiple product. May purchase. So maybe they can have this kind of relationship. So this is one mandatory, 0 many. Okay. Another example. A student may enroll for many classes. A class may have many students enrolled on it. So this is student and this is class entity. Okay, and the relationship is enroll. So a student may enroll for many classes. Okay, a student may enroll for many classes, and a class may have many students enroll in it. Okay. A class may have this is the one many. Okay, a class may have many students enrolled in it. So this is not single one. So it can be like this. Okay, so this shows this is many to many situation. One many. Okay, this makes like this. Okay. Okay, so this is the same, a student and a class, okay, at a time. So student, the same, student, class. Okay, student enroll in a multiple class. At first, it says a student can be enrolled in multiple class, but a class can have many students. So we change from single to multiple. Okay. Next exercise is order table. Order table contains orders placed by multiple customer. Order table. So this is order table. Okay. And this is customer. Customer. Okay. So the relationship is contain. Order table contain orders placed by multiple customers. So order table placed by multiple customer, and a customer may place more than one order. Okay, so this explains to us many to many relationship. Okay. Next, write the business rule from the given ER. Okay, so this is the vice versa from the previous exercise, that is creating the ER from the business rule. Now write a business rule from the ER. So look at the entity we have here, employee and security badge. So this relation is 1 to 1. So in simple word, you can write one employee is assigned to only one security badge. Okay, and one security badge is assigned to one employee. Okay, or you can replace one as a each, also can. Okay, each employee is assigned to only one security badge. Okay, and the other one, so business rule must contain two sentences. Okay, from left to right and right to left. And how about this one? This is many, one to many relationship. Each department or one department has many employees. Okay. And look at this. Each employee is assigned to only one department. Okay, department. Okay. So this is the business rule for the given ER. Okay, I hope you are clear with how to create or transform the business rule from the ER, or vice versa, creating an ER from the given business rule. Okay. As a recap, this is the steps to create an ERD. First, you need to identify the entities. Okay, entity is easy to recognize as they are represented by noun. Then identify the attributes given her qualities or the characteristic of the attribute of the entity, and then identify the relationship. This is also easy to recognize as it usually give by the verbs. Okay, and then you need to link entities to attributes and link entities together via their relationship. Exercise number 1. Customer visit the Centage website to purchase gardening items. Customer may or may not place order at any one time. Customer may or may not place orders at any one time. Each order is assigned. Okay, so this is customer order. Each order assigned a unique order code, and an order may have multiple items. Okay, contains an item. One order can have multiple transactions. One order can have multiple transactions. This customer may add item, change the quantity of item, or even return items after purchase. Relevant customer information includes name, address, and so on. So here maybe this is the conceptual ERD. We have customer. Okay, customer. Then we have order. And what is their relationship? Place, order. Okay, a customer may place 0, okay, orders to many orders. Okay, and each order is assigned a unique order code. So they have this is features for the order. So order code, and they have the item. So order contain item. Okay. Item. One order can have multiple transactions. This customer may add items, change the quantity of items, or even return items after purchase. Okay, so this transaction, okay, so this is actually a customer place 0 to many orders. So, and one order can have only one customer. Okay, and this order also can have a transaction. Okay, transaction. So this is all the information given. Relevant customer information includes name, address, and phone number. Okay, telephone number. So this is all the information given. Okay, so this is the basic ER that can be made given the information like stated in the case study. Okay, so next, create an ER based on the following business rule. Each applicant can submit one or more application. So we can have entities here, applicant, application. So applicant and application. Okay, this is submit. Each, okay, applicant can submit one or more. So this is 1 to many application per year. So each application is submitted by only one applicant. Okay, so this is true. Okay, each school can be associated with one or more applications. So this is school and application. So each application is associated with one only one school. So you can create like this, similar like this. Okay, with one to many relationship. Okay. Each application must include 2 or more recommendations. So application and recommendation. Okay. And finally, each bowling center can be associated with one or more application. Bowling center application. Okay, so based on this situation, the question didn't ask us is not very clear. Either you need to write the ER diagram separately, or make a connection between the only one ER. But from here we can see that create an ER. So it looks like they want to ask you to create only one connecting ER. So we can connect it. So the first one has been done. Then second, each school and application. So we have another school, another entity. Okay. School here. Okay, application. Each school can be associated with one or more application. Associated. Okay. And then school. Each application must include 2 or more recommendation. Recommendation. Each application, okay, include 2 or more. Okay, 2 or more. 2 or more recommendations. So each recommendation is included with only one application. And each bowling center can be associated with one or more application. Center, bowling center. Again, associated relation. Okay, more application. So this will be your ER diagram based on the business rule. But it's quite messy, so please draw it properly during the examination. Okay, so this is all the information we have. Okay. Next, the case study. Suppose you are given the following requirements for the hockey club. So the club has many teams. Each team has a name, city, coach, captain, a set of players. Each player belongs to only one team. Each player has a name, position, skill level, injury records. And then a game is played between 2 teams and has a date and a score. So construct a concise ER. Okay. So first we have club, right? Club, then team, player, and game. So maybe it can be drawn like this. It's a club, and then you can have a team, then a player, and game. Okay, game, team. So a club has many teams. Club has a many team. Just that they do not mention if a team is only registered under one club, but logically it is yes. A team can be only registered for under one club. Okay, and each team has a name. This is attribute name, city, coach, captain, and players. Okay, that's for this. Each player belongs to only one team. Each player belongs to one team. Okay, belongs to only one team. But for a team, they can have a multiple players, a set of players. Each player has a name, position, what else? Position, skill level, and set of injury. Okay, set of injury records. Okay, so from here, teams belong club. Sorry, club as team or register. And then player. A game is played between two teams. So team has a game. Okay, has a game. A game is played between two teams. Okay? Two teams. Okay, two teams. Okay. So this is the basic ER. You can extend this to, for example, this one, set of injury. You can create a table for injury records, and so on. So make a connection like this. But for the examination, this is acceptable. Okay, this set of answer is acceptable. Okay, just important is to write the name to identify the entity clearly and correctly. Okay, and then set of attributes if given, if not, and not mention any assumption, so you can leave it blank. This is not given. And then don't forget to write the relationship and cardinality. Relationship and cardinality. Okay, right. Okay. So then the other case study. A university registrar's office maintains data about the following entities. Okay, so we have the courses, offerings, course offered, student, and instructed. For the enrollment of students in course and grades awarded to students in each course they are enrolled for must be appropriately modeled. So this is the situation. Write a ER diagram for the registrar office. So let us draw the ER. We have course, and then we have student. Okay, so this is the course. Yes, you can write down the attributes here. And for the student, because it is given, student ID, name, program, number, title, credits, and so on. Okay, course offering include course number, year, timings, and classroom. So this is another table actually. Course offerings. And write down the attributes given. And finally, the instructor. Instructor. Okay, instructor. Okay, list of attributes. Okay, from here, title, credits, number. So this is a course number. So I guess this is a course number. Okay, title, credits, syllabus, and prereq. Then course offering, course number. Again, course number, year, semester, section, instructor. Okay, and what else? Timings and classroom. Okay, so you need to write all. Okay, everything given. Then number 4, instructor, ID, name, and so on. Okay, student ID, name. Okay, right. So now the relationship is not given, but from here we can do the assumption like this. cost has something to do with the cost of ring because they contain the same attributes, cost number and cost number. So like this, okay. And cost of a ring contains the instructor name, so it has something to do with the instructor. And for the student, yeah, student, because in this course they only have number, title, credits and syllabus, but they do not have the instructor, the timings, the classroom and so on. So student must be connected to the offering instead of the course. Okay, so this enroll course has has is a basic relationship, okay, contain and so on. Okay, so this is the basic. So then, but then the cardinality and the participation is not mentioned, okay, but you can just write it as a common. Cost offering contains cost has cost offering, okay. The cost can have a multiple cost offering based on the section, okay. Then instructor can have one and only, not only, many instructor, okay. And course, okay, enroll many student, okay. Each student can have one course offering. Okay, so it is difficult to assume the relationship because it's not given. So that's why, again, finding or extracting the business rule is important, okay, in your case, okay, while you are developing a system or the database design itself. Okay, so that's all for the exercise. Hope you can benefit from them and learn something. Thank you.